timeline that you have. All right, so the book we talked about that history. One of the things that you need to be thinking about is the scientific method. And you will be doing a lab starting this Friday. You need to bring that safety contract back tomorrow. So let me write that down on the side here. You have to read it. It's long. Could I see it for a second? There is a spot for you to put your name. You need to put your full name, not your nickname. You need to sign it and date it. You have to answer the questions 56, 57, 58. Your parents need to sign it and date it. You need to print your name where it says I, print your name. Clearly, so I can read it. So a safety contract is due tomorrow. If I don't have the safety contract and you're past safety test by Friday, you cannot do the lab. Or for you, it's by Thursday because you guys do the lab on Thursday. Your scientific method is a way to try to understand a world that is virtually not understandable. We are ants trying to understand an empire. The universe is very difficult to comprehend. The rules can be very complicated. Even something as simple as your body, compared to the universe, is complicated. It's not as simple as 1 + 2 = 3. It's a very complex system. Any one change can change 100 other things. So we have to use a very, very rigorous step-by-step method in order to rule out influences from other factors. We call these factors confounding things that confound, confuse. You should be writing this down. I should see pencils swirling. If I write it on the board, it's important. These confounding factors influence your results. These confounding factors can confuse, cause, and effect. So that's really the danger of any experiment. Your job is to figure out how can we filter out the noise? How do we filter out the noise and really get to what is the cause and effect? What is the relationship between these two variables? Two variables. You're always looking for the relationship between two variables. A and B. What is that relationship? How are they related? Does one increase the other? Does one benefit the other? What is the relationship between these two variables? That's really what you're trying to figure out when you're doing any experiment. So what does that mean? You tell me, what does that mean? What do we have to do if we're going to try to find a relationship between two variables and try to filter out any confounding factors, any factors that might confuse us? What might we have to do? Yeah? Similarities and differences, we're looking for patterns. That's what we're looking for, so that's not a bad answer. It's not answering the question I'm asking, but it's not a bad answer. You should write that down. We're looking, what's the main objective here is we're looking for patterns. They could be similarities, differences. How does one change versus the other? That's what that relationship between the two variables, that's really what we're looking for. We're going to look at a bunch of data and we're trying to find out, is there a pattern here? Is there a pattern in this data that allows us to decipher a possible relationship between two variables? That's a big deal. That's a big deal. What do you need to do in order to do that? Yep.
Experiment?
Yep, you're going to have to experiment. That's certainly the whole point of the scientific method, absolutely. There will be an experiment. What does that mean, though? Is that, to me, the word experiment to students and to most people is very much like the word study. It's very ambiguous, doesn't really have a lot of good definition.
You have to make observations.
Right, okay, so that's good. That's where we start. So like any good experiment, you're going to start with an observation. Then you're going to come up with a question. One old one that people like to think of is Isaac Newton. Say what now? Collected data is one. Yes, that's very good. But let's not jump to that yet. But yeah, you're absolutely right. That is one. Let's just sit over there somewhere, away from her. All right, go ahead. Just go ahead. Go ahead. So yeah, Isaac Newton was sitting under an apple tree, and an apple fell down from the tree. That's not Cornell notes, right? That's not Cornell notes. I don't see Cornell notes format being used. That's going to be a problem for your grades. You divide the paper into 1/3, 2/3. I've told you that. So 1/3, 2/3, where the details, the recording is happening here, and the main ideas here. The main ideas are blank during class. It's only after class that you might want to review and come up with main ideas, reflect, and come up with main ideas. Here you're recording. Unless I write it here in the main ideas, you need to figure out what those main ideas are here later, and then the summary at the bottom. So I don't know why we're not getting the point for some of you, unfortunately, you're going to have to get graded, and that grade is going to have to come back not great for you to get it. But I'm serious about looking for those 6 R's, for looking for that evidence. All right, so the question, you have to come up with a question. Isaac Newton was sitting underneath an apple tree, and what happened? Yeah, the apple fell on his head, or fell down in front of him, whatever the case may be. And Isaac asked the question, why? He asked the question, why? What's the relationship between variables? Why does everything that goes up come back down? What are the factors, and what are the relationship between the factors? What is the relationship between the different factors? So that's an observation that led to a question. So what else? What's the next step? You have a question, you have an observation, you have a question. What do you do next? Yeah.
Hypothesis.
That's right. You come up with an educated guess. You've made some observations. You're an educated individual. You know how things work as best you can. You understand what you understand and what you don't, because you're reflective. You've done some reading, and you come up with a hypothesis. Hypotheses are written in an if this happens, then that happens. If-then statement. If-then statement. What does that suggest? If then. Think about all the things we just talked about a minute ago. What does that suggest?
Cause and effect.
Cause and effect. Requiring what? How many factors? 2. From the very beginning, we're limiting ourselves to 2 factors. We observed, we asked a question, our guess as to the relationship between 2 factors. If A, then B. Always 2 factors. Anything more than that, it's hard for us to really start to unpack that, to take away confounding factors. We're going to be working with plants on Friday. Let me give you a real simple example. I'm growing plants, and I want to know what is the impact of sunlight on plants. What do I need to do? Yeah.
Put some in front of like a window with light, and then put a few others in like a corner.
That's right. Put some in light and others in not so much light. But what else do I have to do? Yeah.
Make sure you give them the same amount of water, same amount.
That's exactly. I have to control every other factor. Because if I don't, how do I know that the one that I put here in the light just didn't have more water, and the one over there didn't grow because it didn't have enough water? So I have to control everything else has to be the same. The only difference between the two must be that factor we're looking at. Does that make sense? How much sunlight and how much does it grow? Those are the 2 factors. All right? So we're looking for 2 factors. We come up with a hypothesis. Then we have to design an experiment. Somebody said earlier, experiment. We have to design an experiment. I'm just going to put experiment here. And then over here, I'm going to put design it. That's what you're going to be doing this week. You're going to be designing an experiment. You'll get the lab in just a minute. There's a lot of steps. You'll be set into groups, and you're gonna design an experiment. It won't be as simple as sunlight on plants. We're going to control the amount of sunlight the plants get. We're going to control the amount of water. It's going to have to do with salt concentration in the solution. So in any case, we're going to design an experiment. You're going to make sure all the other factors, as many as you can, are kept constant. The only one you're going to change is the salt concentration of the water. So let's talk a little bit about design, experimental design. We already said all factors I'm going to use the word variable, if you don't mind. All variables will be constant. Or let's just use the word the same, because that will be the same. If they change, they're going to change the same. It means we're controlling all the variables that we can. The amount of water, the amount of soil, the types of seeds, the amount of sunlight, all that will be controlled. All right. There are 2 things we're not going to control. What are the 2 variables except for what? What 2 variables are we not going to control? You're right, the outcome, you're right. It is the outcome, but what 2 variables? Yeah.
Well, A and B. Right?
A and B, yeah, except for A and B. Except for A and B. Those are the only 2 we don't control. We do control it, but they don't stay the same. Those are the only 2 that don't stay the same. We control A, we don't control B. We don't control, as someone said, the outcome. The outcome is what it's going to be. That's what we're looking at. So A is going to be the one we change. The variable we change is A. The variable we change is A. Also known as the independent variable. If you've done your reading, maybe you covered it in middle school. If you've done your homework, that's certainly the independent variable. So that's the one we change, the one we control. The outcome, which I love the way you said that. I love the way you said that outcome. The outcome we don't control either. We don't have it. We just want to see what is the relationship between A and B. I'm going to change A, and I'm going to see what happens to B. But what is A theoretically, according to our hypothesis, what is B dependent on? A. So we call that the dependent variable. So B is the variable, or the dependent variable, in this case B, is the variable that changes because of A, of the independent variable. When we graph, and you will be graphing, the independent variable always goes on the x, and the dependent variable always goes on the y. So you need to know that much as well. Independent variable always goes on the x. The dependent always goes on the y. Should be taking notes, not worrying about that. We have no time for that. If you are doing anything other than taking notes, when we're taking notes, you're hurting yourselves. Focus it one thing at a time. You must be in the moment. You cannot be distracted. Distraction will lead to errors. Errors are going to occur anyways. Our job is to minimize the errors. So dependent variable and independent variable, those are the two variables, A and B, that we write in our hypothesis. If I give a lot of if the plant receives more sunlight, then it will grow better. So the relationship between sunlight and growth is clearly demonstrated. Growth is dependent on sunlight in our hypothesis. So growth is the dependent variable, sunlight's the independent variable. We will control how much sunlight the plant will get. We will put it in the window or in the corner, according to the example that someone gave me earlier. Yes?
If we wrote this down on our previous notes, do you think we should still write this down?
Previous notes, you mean from the chapter? Yeah. That's a really good point. What I like to do you need to write it down again? No. But I would say see chapter notes. Yes, your chapter notes should be in there. Maybe highlight those notes that you somehow when I go to grade your notebook, it's a really great question. It's a perfect question actually, because your notebooks will be graded in a couple weeks. So you wrote it down, you did your homework, you wrote it down. We're in class, we're covering it in class. Do you write it down again? You could, because maybe you want to keep a record of all the stuff that we covered in class. That's possible. A better way, I think more efficient way, is to go, since your chapter notes are right there in the binder, you can go back and highlight and say this was covered in class. Or put a little note, covered it in class. Or somehow have a code. Like I had students that would put an asterisk by everything that was covered in class. So they don't have to rewrite it. It seems like it's a redundant thing to do. And also, it allows them to reflect on whether they understand it or not. And it also helps them understand it is important, since they read in the chapter, they covered it in class, and they might even get a quiz on it. They might even get a quiz on it. Not clicking. Okay. Some deadpan eyes. So now we designed the experiment. Are those all the variables we have to worry about? So I take and I put some seeds in a. I'm asking you. This is a question. It means that requires you to actually look at me and think. So nothing on the board right now. Look up here. Or down here, or over here, wherever I am. So let me ask you something. I have two groups, A and B. A is my independent variable, the amount of sunlight. B is how much they grow. I controlled all the other variables. I plant 10 plants and I put them in the windowsill, and I put 10 plants in the dark, or less light. The ones by the windowsill grow better. The ones in less light don't grow better. Am I done? Did I prove my point? Is there a relationship between growth and sunlight? If so, okay. If not, why not? I'll give you a hint. No, I have not. If you wrote that up and submitted it to a scientific committee, they would tear you apart. Literally. It's vicious. What's the problem with what I just said? It makes sense. Let me say this. What I just described is fine, but you're missing a big piece. And some would argue the most essential piece in all of science. Yeah. It's a really good point. I wouldn't call it the most essential part, but yeah, a report is important because you need to actually have a conclusion, you have to present it and discuss it. So yeah, that's an important piece of the scientific process. But in this experimental design, when we put an independent variable, dependent variable, we're controlling how much water is in both groups, in both the light group and the dark group. What's the problem with that design? Why is there a problem? Here's what. One answer, and then I'll give you a question. Yeah.
I was gonna say you have to jot down your data.
You have to what?
You have to write down your data.
Yeah, all that'll come later, but just in design, not in doing. Why are you still putting it away? Why are you putting your notes away? Why? Is it time to go? Is it time to go? So you got another minute? So you put it away a minute before class though. So it wasn't time to go when you put stuff away. Just check. So that's your, consider that extra homework. What's the problem with that design? What is it that's missing? That 20 minutes cost us, guys. I will post you'll find the answer in the video for the next classes. So what's the problem with this design? There is an essential problem. You probably have heard it, yeah.
It's formally theory.
No, you don't have to jump around. It's not jumping around. You're missing a piece here at this stage. Something is wrong. We got our two groups, our independent and dependent group variables. We're fine, but there's something wrong here. Something that will not allow you to say anything about the relationship between sunlight and growth. So let's be clear. We have a plant. Is it time to go? Where's the people?
No, it's just
It's very loud at this point. That's in the direct sunlight. You have a bunch of these. You see how fast they grow in a given amount of time, how high they move. So you're going to measure how tall they get. The soil is the same. Soil is the same. And we have this shaded area over here that's not in direct sunlight, and we're going to try to grow some plants there. We assume that the plants will be smaller because they have less, and they won't grow as fast. Their height would be shorter. We assume that. We don't know that. We're going to collect that data. Two groups, shaded and direct sunlight. And we're also said, this is what we said so far, all other variables are controlled. It's a big deal. All right, so there's two groups. So what's the problem? I don't understand. Why did it get kicked back by the committee? Why does someone say this is not good science? What's the issue? We have two groups. We have the shaded group, group 2. You have group 1. These are known as experimental groups. We did control, we have all the other variables controlled. The water, soil, air are all controlled. What someone mentioned we're missing something. What group are we missing? The control group is missing. We need a control group. Sometimes 2 control groups, really ideally. What would be a control group for this experiment? What do control groups do? What's the point of control groups? A comparison. So controls are meant for comparison. So you say to me that these grew higher than these, the daylight, we kept all the other variables the same. I would say, how do you know there was just something in the shade, in the soil? How do you know, for instance, that it was sunlight and not something from the window that the sun hit that let the plant grow? How do you know that that particular area where the sun was direct sunlight didn't have some insect that allowed this plant to get fertilized versus this plant? How do we know that it wasn't something that this group had that we can't see, feel, or touch, like the dark matter and dark energy we talked about earlier, right? How do we know there's something that we don't know about that's making this grow faster than this? Answer, we don't, unless we have a control group. So what we would do then is we would take and plant the seed in a control group that's in total darkness, absence of light. This would be your negative control. Negative control. In this particular experiment, a positive control might be not as useful, but maybe here you have kind of medium light, 5 hours. It doesn't seem like it's reasonable, but, or you know what? Maybe these are, I don't know. I can't think of a positive control right now, but here you would have a positive control. Why do we call that negative and this one positive?
Because you expect it to go wrong?
That's right. Excellent. We expect no growth. You know what? Just for argument's sake, it's 24 hours. Light. All right. So here you'd expect to have max growth. So here you'd expect that that there would be growth. Here you'd expect no growth. If there's growth in total darkness, something's wrong. Correct? If there's no growth, if these don't grow at all in 24 hours of light, then something's wrong. Then we have to figure out what factor that we weren't thinking of, what was that confounding factor that's messing up our experiments. So this experiment is beautifully set up as you guys set it up. Would mean nothing without having a control group that allowed us to compare the results to. To say, you know what, we know that these plants don't grow without any light. We know they grow with 24 hours light, given that we control all these variables. So now what happens when I decrease the amount of light or increase the amount of light? How now I can talk about how much sunlight impacts growth rate. Fair? So it's these control groups are essential. So your design, when you're designing your experiment for Thursday, you're going to have to consider control groups. All right, so control groups are essential. And when you're looking at experimental design, you guys can define it in your own words. So this is, again, Cornell notes. Main idea. It's not the only main idea. Just put one example here. Here's the details that you just recorded. This is something you would do at home. And, of course, your summary you would do at home or when you're studying with your friends or reading your book. I had a student in 9th grade because they're reading a similar chapter to yours. Obviously, there's a simpler, okay, because they're a non-AP course. But their chapter 1 also talked about control groups, also talked about positive and negative controls, also talked about the idea of dependent, independent variable. And they asked a question. They raised their hand and asked a question. They said, Mr. Mendoza, I already took the notes from the chapter. I wrote this down in the chapter. Do I have to write it again now off the board? That was a really great question. My suggestion to her was, no. The best thing you can do, since you should have a 3-ring binder with loose leaf paper in it, not a spiral notebook, then you could take the notes that you took from the chapter and put them right in front of today's notes, and you could highlight, circle, put an asterisk by what you wrote down in the book and say, we covered it in class. So the stuff that you read in the book and we covered in class, that should be a key for you that's important. Does that make sense? And obviously you'll find it on quizzes, and you'll hear it in the little daily videos the AP Classroom gives you, etc. All right, so let's quickly go over what we said. We said there's observations. I'm just going to use abbreviations here. We made observations. We came up with a question. And then that question led to hypothesis. That hypothesis was if A, then B. Then that led to experiment. We designed our experiment. Is it time to go? Is that why people are putting things on?
Yeah.
How much time do we have left? Is that it? We're done?
Yeah.
All right. So we'll finish this tomorrow. Hopefully with less drama than today. Have a good one.